Good afternoon. I'm Kai Chen from Social Sciences Computing of University of California at Los Angeles, and I'm the lead programmer of the UCLA Communication Studies Archive. I'm happy to be here with you and talk about the project, its background and setup, how we have implemented certain things, and so on. And I hope you'll find this presentation interesting and useful. So this project started as a continuation of analog recording of television news. Back in the Watergate years, a professor in the now Communication Studies department started recording television news. Over the years, thousands of tapes have been recorded. Obviously, it's not very convenient to go back to the tapes or the collection of tapes to look for a particular news program or topic in the collection. So in 2005, two professors at the department started recording television news digitally using computers and TV capture cards. This new system has several advantages over the old one. It stores videos that can be streamed over the web. It records closed captioning, which is commonly called subtitle text, and comes with most TV programs in the US. The recorded text is indexed and searchable thanks to Lucene. The system captures image snapshots. Finally, we have built a search engine as well as some analysis tools for the archive. Besides recording news programs from television, we also get them from other sources. For example, for CNN television, we recorded news programs, but their websites also has transcripts for many of the shows. So for these shows, we now have this transcript alongside with the closed captioning. There are also television news programming, such as Democracy Now! And Russia Today, that broadcast on the web. And we download the shows also. The digital archive grows at about 100 news programs and 600,000 words each day. Right now, it contains television programming from 28 networks and 1,600 shows. It has 130,000 hours, 160,000 news programs, 50 million still images, and 880 million words. So why is this project important? For many researchers, the archive is a large and unique collection of human communication. Unlike many other collections, this one captures many communication modalities, such as speech, facial expression, body gesture, and so on. News content has different conditions and settings. Some are staged and scripted, and some, such as interviewing eyewitnesses, are not. And there's single speaker scenes, conversations, debates, and so on. The news programs are also from different networks and communities. The archive allows the study of TV news, like how people have studied written news from newspaper archives before. It allows the study of television news in particular and communications in general in ways that were impossible before. For example, to use our analog connection as well as other tape-based video connections, people often need to know which tape what they're looking for are on, and there's often a non-trivial cost to check out particular tapes. For example, it involves finding, copying, and maybe mailing each tape also. Taking a quick look at or extracting some details from a large number of news programs is hard, if possible at all. In contrast, our digital collection is searchable and accessible from the web, and it allows to do what I just described easily. Researchers all over the world can access the archive's material simultaneously and instantly. For non-researchers, including myself, why should they care? Some of them might say that there's very little that they can learn from and conclude from TV news, other than say they are all biased. But I disagree. TV news is about presentation and persuasion, and those who create news content have their own angles and opinions about the news story. And news programs are a medium in which they basically persuade us to think the same. However, presentation and persuasion happens in our daily lives also. The difference is that unlike those that happen in our daily lives, those in TV news can be readily recorded and systematically analyzed and studied, and tell us something about communication in general too. Also, even in recent years, when the internet and social networks become more popular than ever, TV remains the main source from which most people get the news from. What they see in TV news greatly affects the public opinion and decisions in public policy and other areas. If what we watch is so important, we really should learn about it and be conscious about what we watch. And now is a good time to mention that the archive's content is copyright restricted and is to be used for academic research and teaching. However, for researchers and students fortunate enough to have access to the archive will hopefully empower them and change their lives in some positive ways. Here is what the search engine interface looks like. And you can notice that it is quite different from a regular document search engine. There are 3 display formats: list, table, and chart. I'll show you each of them and later talk about the implementation side later. And users can enter multiple words, phrases, and regular expression patterns. And there are several criteria such as with all the words, with at least one of the words, without the words, and with all the words within a certain distance. And you can notice that in this screenshot, the distance says the same segment around here. And I'll talk about the story segments later, but the distance can be in words, segments, or seconds. For the list formats, the users can select how many search results per page. And in addition, the search results can be filtered by date, number, and show series. The search result can be sorted by score or date. Yes, it does require login. And right now it's basically restricted to students on UCLA. And here is how the search result looks in the list format. It looks closest to a typical document search, but we have gone beyond just showing what news programs are matched. Since we have the closed captioning and images, the search result page shows where the matches are inside news programs. The position that the search words, phrases, and all patterns are matched are highlighted with text around them shown to show the context. At each match position, there's a permalink for referring to that position from external bookmarks and reports. And there is an image snapshot of the video at that position. There's a video player on the same page. If you click on the image snapshot, it starts the video streaming and jumps to that position in the video. Here are some larger screenshots of the search result of the list format. Hopefully they show better how the context, the highlighting, and the image snapshots work. As you can see, highlighting works for words, phrases, as well as regular expression patterns. Table and chart display formats are very useful for showing how the use of certain words, phrases, or language patterns vary by time, network, and show. As well as, yes.
So when the user searches for a phrase and they play the video, context in the video clip?
Yes, it will be the same highlighting, but the whole phrase will be highlighted.
But if I'm switching from financial crisis and it's somewhere in a half-hour news block, do I jump right to where they're talking about financial crisis?
Yes, if let's say it happens half an hour into the show, then it will jump into half an hour into the show. No problem. And the table and chart formats are very useful for showing how the use of words, languages, and phrases or language patterns vary with time, network, and show, as well as displaying, showing how a word is used together with or instead of another word. For example, for these two display formats, the search results are not listed by news program but are put into groups. For example, by day, week, month, year, or network or show series. Again, they can be filtered by date, network, and show or series. Here is how the search result looks in the table format. This sample query searches document and occurrences count of two words, crisis and bailout, from September 11 to October 1st, 2008, which was when Lehman Brothers bankruptcy sparked a financial crisis. There's a column for each of the two words, a column to show the frequency of either word occurring, plus a column for the total numbers of news programs in that group. The rows are days in the date range. The cells show the number of news programs and occurrences of the words indicated by the column heading, on the date indicated by the row heading. Here is the same search result in the chart format. The values represent weekends when we record fewer shows, but you can still see the general trend. Right after the Lehman Brothers bankruptcy, there was a sharp jump in the mentioning of the word crisis, but the word bailout was mentioned less until later in the month. But by the end of the month, bailout greatly surpassed crisis. Here is the chart result for different query, which is the number of times two presidential candidates' names, Romney and Santorum, are mentioned in the course of the campaigns. The archive is being used in research in several fields. Communication studies, researchers analyze the amount of coverage of events over time. Examples are the Second Iraq War, the 2008 South Ossetia War, and then the 2011 Norway attacks. Linguistic researchers use the archive to study speech and language patterns. Computer science research topics include identifying objects and people in the news, as well as story segmentation. In fact, researchers from these three fields are joining together to study visual and verbal interaction and persuasion with the archive, with the support of a grant from the National Science Foundation. The archive has been used in teaching several classes. An example is a Chicano Studies class on representation of Latinos on the television news. Its focus was on studying the May 1st, 2007 immigration march, with an emphasis on the use of police force at MacArthur Park in Los Angeles, California. Students studied 2 days of television news program, in which they were to identify framing, stereotyping, metaphor, and silencing. The archive allowed them to better show what they learned. For example, instead of just citing KCBS News at 11 p.m. on May 1st, 2007, they could point to 2 minutes, 12 seconds into a program by including permalink and a screenshot in the report. Other examples are 2 communication study classes on presidential communication. In one class, students studied television coverage of the 2008 presidential primary election through 6 weeks of selected news programs after the primary election. Students analyzed coverage of soundbites from candidates. They collect the amount of time given to each candidate and party, and the types of responses given by the news anchor or portrayed by the news programs. In another class, students create their own political TV advertisements, similar to the ads we see on TV about public officials, from the archive's news footage. We have 4 video capture and conversion machines in production, divided into 2 groups. Each group covers half of the recording schedule and has two machines recording the same news programs at the same time for that redundancy. The better recording of the 2 is kept. There are 6 TV tuners per machine. Video is captured in the MPEG-TS format at about 7 gigs per hour. Closed captioning text is recorded with a timestamp every 2 or 3 seconds. Afterwards, the system generates image snapshots from the videos and converts the videos to MP4 H.264 format in VGA resolution at about 240 megs per hour. The control servers downloads the electronic TV schedules as well as web stream news programs. It collects and checks recordings from the captured conversion machines. It stores a copy of the files and also pushes them to the backup storage server, the image server, the video streaming server, and the search server. The search server updates the Lucene index daily. The indexing process stores and tokenizes the main closed captioning text field. It creates separate fields for days, network, show, and so on. It also creates binary fields for segments and time data that I will talk about later. This server hosts the archive search engine. The search result page contains videos and images that come from separate servers, but the main result comes from the search server. It has a front end with a web server and PHP custom code, which formats the search form and the search result. In the back end, there's Lucene, a Lucene index, and a MySQL database. There's custom Java code that extends Lucene what Lucene provides into what we want. It allows our search engine to handle query types and result formats beyond the Lucene built-in ones. A bridge allows the front and back ends to talk to each other. We are using PHP Java bridge in production, but I'm replacing it with Solr. Our use of Solr will be different from many others, and we will have a custom Solr request handler to handle requests. However, we can still make use of Solr's thread management, caching, serialization, and so on. Lucene is great because it gives us the end results plus low-level data and building blocks from which we have built custom queries. One of them is segments and closed queries. Let's consider the problem of how to search for X near Z. Lucene can search for X within Y words of Z, but how do we pick up Y to search to solve a problem? Because no fixed number works everywhere. A related problem is that even a news program matches several words, this word might not be all used in this news program to talk about the same story. For example, if you search for these words, Obama visit and Afghanistan, you might expect to find something about President Obama's visit to Afghanistan. However, the query would also match a news program that talks about Obama's visit to, say, Canada, as well as violence in Afghanistan. This news program is probably not what you have in mind. A characteristic common in many of the news programs is that each of them covers many stories. For example, an hour-long evening news might start with a few local stories, then national and world stories, and then weather, sports, and so on. If you draw a timeline for a news program, these stories show up as segments in the timeline. Let me show you what story segments look like. The left side shows a simplified view of an evening news I just described. The right side shows an actual story segment from an hour of CNN newsroom. In this particular program, there's 26 story segments plus 6 commercial block segments. A solution or an approximation for finding X near Z is that we consider X and Z to be near each other if they're within the same story segment in the news program. This is possible with Lucene if we give it information about story segments. A bonus from this solution is that it also enables searching and filtering for a particular news type, story type. For example, a political science researcher might be more interested in news program, a section of them about politics, and less interested in the other news program or sections of them. Computer science researchers have been working on automated ways to find segments using, for example, word frequency, scene change, break frame, and silence. On the other hand, some communication studies researchers are doing manual segmentation on some of the news programs. They will watch a video, decide where a story starts and ends, and mark the position, process stories, type, and topic in a semi-automated system. And since I'm going to use the word span later, and I'm going to explain it. A span is a section of a document that are query matches. The big picture of segment enclosed query is that a span is matches should be fully enclosed by a segment. In this program, span 1 is enclosed by segment 1, but none of the other 4 spans are enclosed by any of the 3 segments. We implemented segment enclosed query by getting spans from span near query, which comes with Lucene, and then filtering and keeping those that are located fully within any segments. Right now, in production, segment information is stored as a list of start position and position pairs. This approach is relatively simple to implement. We just put a list in a store view of the document. Searching is reasonably fast too. An alternative with developing is to store each segment starting and ending point as terms. This way it's possible to search for a particular story topic, and it appears to run much faster also. Time enclosed query is similar to segment enclosed query. The idea is that based on timestamps and the position time mapping that we have, we can calculate the maximum length of each span in terms of seconds. Then you can search for, let's say, X within 15 seconds of Z. The search engine gets spans by span near query, which is built into Lucene, and then filters and keeps those we know are no longer than 15 seconds each. The implementation is similar to segment enclosed query, except we have found that just storing the timestamp position information as an array works better. Storing it as terms take much more disk space, and unlike segments, there's less need to search for a particular timestamp. Multi-term record expression is another type of custom query we have implemented recently. As I mentioned before, linguists want to find word patterns, such as here is 4x3 words with the followed by news or story or details or report. They want to use regular expression to look for a phrase or sentence, not just individual words. In fact, they want to run the Unix grep command to match a pattern against the whole text collection, and of course that's very slow. We think we can make many of their use cases run faster with Lucene. The good news is Lucene has some built-in record expression query support. It's a good starting point, but not a complete solution for us. Some analyzers do not work with regex and cannot give you a regex pattern as a term. But there's a bigger problem. Lucene's regex query classes only match a pattern within individual terms, and a pattern only describes how one term should look like. However, that's not what the researchers want. And they also want to mix words with placeholder for a specific number of any words. For example, we know in regex, ... means 3 consecutive characters of any kind, such as the. But our researchers also want something that matches 3 words of any kind, such as with the details. Another implementation issue is you cannot just tell Lucene to find all documents and operation where any word occurs. It gets very slow and takes lots of memory because you are basically asking it to return the whole database to you. What we did was to parse and translate a multi-word regex pattern into a proximity query that Lucene understands. For example, the pattern here is followed by 3 words, followed by with the equals to a phrase. Here is followed by the phrase with exactly 3 words in between, and Lucene understands the latter. Leading and trailing placeholders are an issue. An example is a pattern 2 words followed by 3 words. We cannot just discard these placeholders at the beginning and at the end, and there are no equivalent Lucene built-in queries. Instead, we store a number of words in each document, expand each span on both sides, taking the placeholders into account, and make sure that the span does not extend outside the document's range. Lucene uses Java built-in regular expression library, but also let you pick your own. Several of them are available, and they differ in syntax, capabilities, and speed. For example, some have Perl-compatible regex syntaxes. Some let you have back references in your patterns, and some are way faster than others. For applications that use regular expressions a lot, it's worthwhile to experiment instead of just using the built-in one. Another concern is memory usage. Memory requirement to run a regex query is proportional to the amount of terms matched. You might have no problem searching with very specific queries, but run into out-of-memory errors for very broad ones, such as matching any words that end with ed. For us, luckily, giving Lucene more memory solves the problem for now. But if another system has much more terms, they might run into a problem and might need to make the memory requirement scale better. You have seen the table and chart display formats before. Here is how they work under the hood. Here, there are subqueries, general words, to be counted and their groups, which are days in this case. Then we have a table like this. Each cell contains the number of news programs and places, where the subquery matches and the news programs belongs to a specific group. For example, to get the counts for the highlighted cell, we get the queries that correspond to the word meltdown, get the spans it matches in the index, go through each span and count those that are in the news program on September 15, 2008. Let me talk about some of the unfinished challenges. First of all, our researchers are starting to work on analysis of the whole database. Instead of just seeing the first 10 or 100 results, they might want to see the whole search result set or export it to another program. Queries like this are intensive and take a long time. Just increasing the website's timeout doesn't solve our problems, such as what if the user closes the browser, or if we restart the search backend. Eventually, we need a job querying system that can run queries in background and let users come back later and get the results. The system can notify users if their queries have finished or failed. They can restart queries with recoverable errors, check or cancel the jobs, and download the results. The system will allow users to define queries that are scheduled to run repeatedly. For example, they can monitor trends by running queries that would run each day on the new documents that are added to the database. The system would also make it possible to have job priorities and coders in place. Some news programs are bilingual. For example, some key NBC news programs have English and Spanish closed captionings. There are more than one way to get text and timestamps. For example, CNN's website has transcripts for their programs. We can get another copy of the text from the video using speech-to-text. We can manually correct text and timestamps. We are also getting starting to get news program in other countries, such as Norway and Denmark. As we added materials in English and other languages, we need a way to detect and label which language a piece of text is in. Fortunately, libraries to do that already exist. We already know which channel or source a piece of text is from. Searching for specific channels is easier to implement, but it might be less useful than, say, show me only the Spanish content. However, there's no fixed channel to language mapping. For example, there are 4 closed captioning channels, and usually the first channel is English and the third one is Spanish, but not always. Also, when there are multiple channels or languages, what proximity search and occurrence counting should return might also change. There are several types of metadata for the news program, and the variety will only grow. For example, we have talked about Solr segments before. Besides, download transcripts have headlines, descriptions, website link, and so on. Language researchers might also add syntactic tags, such as notate the part of speech of each word. Other researchers can add annotations generated from their research. For example, when they identify an object or speaker in the video, they can add annotations to our story closed captioning. Other users can add arbitrary annotations, such as description of a particular scene. There's also screen text, which is the scrolled text that appears at the bottom of many of the CNN and Fox News programs. Right now, we have a page to display a news program, its text, and all metadata associated with it. It's enough for now, but eventually we want to have most of the metadata searchable also. So that's all the slides I've prepared. If you have any questions about the presentation or project, feel free to let me know, and I'm happy to answer your questions. Or you can email me at this the address on the slide, and the slides will be available at this URL shortly later. Are there any questions? So the question is if there are any similar websites or projects that's targeted for like non-research purposes. I think there are a few. First, I don't remember the name right now, but there's one that I think specializes on C-SPAN's video. Like they do recording of like Congress meeting and so on. Yeah, those are. I think it depends. They might be targeted and like a general public and have like less restrictions in place. Oh, so the question is how to know what time a word is at, right? We have times, as I've said, we have timestamp every 2 or 3 seconds. So if, let's say we record a line and we have the timestamp for that line of text, so we know within say 2 or 3 seconds of accuracy, what time all the words in the sentence is at, basically. We treat one news program as one document, but we also have some more information that identify individual words and what time they're in. So the question is there any libraries we have created to plug our code into other programs like MIF TVs, right? Not currently, actually. Yeah, we basically have this system and we're not doing anything to plug it into other, so that other users can record it yet, right? At the moment. Okay, I'll be available afterwards if you have more questions. But thank you for coming.